Hello classmates, our life and practical application are closely linked. In this lesson, we will continue to explore the mystery of sinusoidal alternating current. We studied power of sinusoidal alternating current last class. In this lesson, we will study power factor of sinusoidal alternating current. What is the power factor? Power factor refers to active power of AC circuit, ratio to apparent power, expressed by lambda. That is, lambda equals cosine phi equals active power P divided by apparent power S. The power factor is numerically equals to the ratio of active power to apparent power. It is a coefficient to measure the efficiency of electrical equipment. It is also a measure of enterprise power supply system. One of the important indicators of electrical energy utilization. The power supply capacity of a power supply device is usually expressed in terms of apparent power. Literally, the power we can see is apparent power, but not real power. Its real power is determined by product of apparent power and power factor. So, the power factor is a very important power supply index. Electrical equipment operates under a certain voltage and power, while a higher power factor value leads to greater efficiency. Generating equipment can be more fully utilized, and its size depends on the nature of the circuit load. The power factor of a purely resistive load is usually 1, such as incandescent lamps, resistance furnace, etc. The power factors of inductive loads are all less than 1. For example, AC asynchronous motor. When it is operating without a load, the power factor is 0.83 to 0.85. In order to make efficient use of electric energy in accordance with the National Energy Conservation and Emission Reduction policies, the State Electric Power Department regulates that power factor of power consumption enterprises must be maintained above 0.85. Those exceeding this benchmark will receive rewards, while those falling below it will be subject to fines. Power supply will be stopped for those with a power factor below 0.5. Therefore, it is imperative to improve the power factor in order to make power plants and power supply stations more efficiently utilize resources and carry out the conversion and transmission of electrical energy. It is essential to distribute active power and reactive power reasonably. Under the condition of reasonable reactive power configuration, efforts should be made to generate as much active power as possible and reduce the output of reactive power. This requires an improvement in power factor of electrical equipment. When the transmitted active power in the power supply system is maintained at a constant level, an increase in reactive power, that is, reduction of power factor, can lead to several consequences. Firstly, the capacity of power supply equipment cannot be fully utilized. Secondly, there is an increase in power loss on the transmission lines. Thirdly, the total current in the system increases, resulting in voltage loss and difficulties in voltage regulation. Furthermore, for generators, the temperature of the rotor rises, leading to an inability to achieve the expected output. Lastly, due to the increase in system current, the system voltage decreases, causing other equipment to malfunction. Therefore, it is crucial to improve the power factor of the power supply system. What has been discussed above is the case of a generator. Its conclusion also applies to a factory or power consumption system in an area. Improvement of power factor means that the power generation equipment in the power grid has been fully utilized. The active power output by the generator is improved, and the transmission capacity of active power on the transmission line at the same time. Power loss of the transmission system is also greatly reduced, which can save a lot of electricity. For example, in the last class, we studied power triangle, where two of its sides represent active power and reactive power, and the hypotenuse represents apparent power. Angle between active power and apparent power is the power factor angle. Cosine value of power factor angle corresponds to the power factor. The less the reactive power, the smaller the power factor angle. And the greater the cosine value, as a result, the closer the active power and apparent power are. In other words, this signifies a higher energy conversion efficiency. This raises a question: how to reduce the reactive power output of a generator? Or how to reduce the reactive power absorption of inductive loads, thereby improving the power factor in daily life. Common electrical equipment such as motors, power frequency furnaces, and fluorescent lamps are all inductive loads, leading to a significant reduction in power factor. To address this issue, the power factor of individual load circuits can be improved by employing a compensation method of parallel connection of an appropriate size capacitive element at both ends of the inductive load, as shown in Figure 371. The essence of improving power factor can be explained by the energy exchange between inductive components and capacitive elements by minimizing the energy exchange between inductive elements and the power supply, that is, reducing the reactive power of the circuit. Q equals QL minus QC. A larger proportion of the energy from the power supply can be consumed by the load. In order to deepen your understanding and mastering the knowledge of this lesson, let's look at an example. In this lesson, we learned about power factor, significance of improving power factor, and how to improve it. These are important knowledge points to help you consolidate these concepts. Here are 2 questions for you to contemplate. I hope everyone will answer them seriously after class. I'll see you next time.